Before we begin today, I would like to remind you that a substitute in this room is a guest, someone that doesn't normally belong here. When you have guests at home, your parents expect you to be on your best behavior. I expect the same of you today with the substitute. The substitute can and will leave names of anyone that misbehaves. So make sure you are on your best behavior today and follow the directions in this video exactly. If you did not read the blackboard as you came in, you are going to need a composition book, a glue stick, and a highlighter. If you do not have those 3 items out on your desk at this time, pause the video and pull those supplies out onto your desk at this time. Now that you have your supplies out, the first thing we need to do is look at your syllabus, which we glued into the front cover of your composition book the first week of school. This syllabus lists everything you are going to learn this year. As we go through each unit, we are going to highlight the topics that we cover. Anything that is highlighted is fair game for me to ask you questions about on quizzes and tests. So you need to make sure you're remembering how to do these things. So every weekend, spend 10-15 minutes looking over your syllabus at the highlighted items and review those topics either by looking back at your notes or by creating extra problems or going into Google Classroom and playing the games that we played when we were doing these units. The 4 topics that are on here that were on your test yesterday were the 2 topics on integers, which the first ones are found in the number and number sense category about halfway down. Identify, represent, order, and compare integers, and identify and describe absolute value of integers. The second part of the unit was in the measurement and geometry section. That was our coordinate plane. Again, it's about halfway down. Identify the coordinates of a point in a coordinate plane and graph ordered pairs in a coordinate plane. When you are done highlighting those 4 topics, we're going to turn to the table of contents and start our next unit. In your table of contents, you already have several things filled in. Those were all from our first unit. So draw a line across there. And our next topic on 9-11 is ratios. We're going to start our ratios on page 9. There are 2 pages of notes on ratios. When you glue them in, make sure you put them in the right order. Part 1 goes on page 9. Part 2 goes on page 10. Pause the video while you glue those in right now. Now that they are glued in, let's go ahead and talk about ratios. Ratio is a new word in 6th grade math, but it may not be a new word to you. If you have ever bought a computer screen or a television, you may have looked at what's called the aspect ratio on your screen. And what that is, it's a comparison of the length of the screen and the width of the screen. If you play video games, you may have heard about a kill ratio, and that's a comparison of your kills to your lives. These 2 examples are only 2 examples of many different ratios, but all ratios are the same thing. They are all simply a comparison of 2 numbers using division. There are three types of numbers that can be compared, three different comparisons or forms of ratios. The first one is called part to part. That is where you're comparing part of a group to another part of the same group. For example, we could compare the boys in this class being part to the girls in this class being another part. The two parts don't have to add up to the whole, though. We could talk about comparing the part of the class that has shorts on to the part of the class that has pants on. That may leave out anyone in the room that is wearing capris, leggings, or skirts. Another form of a ratio is our part to whole. This is the most common form of ratio. An example of that would be the boys in this class to all students in this class, with the boys being part of it and all students being the whole thing. Every fraction that you have dealt with up to now is a part to whole comparison, with the numerator being the part, whether it's the part that's shaded, part that's eaten, part that's left, and the denominator being a number of pieces in the whole thing. That's a part to whole comparison. And the last type is a whole to whole. And an example of this would be the students in this class being our whole class, and the students in Ms. Proko's class being her whole class. So when we're talking about ratios, we can be talking about a part-to-part comparison, a part-to-whole comparison, or a whole-to-whole comparison. There are three ways to write them. You're very familiar with the first method, which is the fraction form. And like I said, all of the fractions you've dealt with so far are ratios. The fraction form is written as a number. We're going to use A here in our formula because A could represent any number, over B, which represents another value of some sort. So any number over another. You may also see the fraction bar written with a slash rather than directly above and below. They're both fractions, and they both represent a number compared to or divided by another number. So an example with numbers would be, say I have 12 apples and I have 24 oranges. So the ratio of apples to oranges in my bag of fruit is 12 to 24. The colon form is a method that you may be familiar with if you've looked at aspect ratio of screens before. They are written with a colon, and a colon are the two dots to separate things. And we can use the same A to B there. I could write my same ratio of 12 to 24 using the colon. Oops, sorry about that. 12 to 24. And it means the exact same thing as when I use the fraction bar. And the third method is word form, and that's where you just write it out the way it's read. The whole time I've been saying A to B, whether I wrote it as a fraction or a colon. I could write it A to B. It means the same thing. So I could do my example of apples to oranges as 12 to 24. All three of those ratios mean the exact same thing and represent the exact same set of data, my 12 apples and my 24 oranges. The important thing to remember with ratios is that order matters. If I ask for the ratio of oranges to apples instead of apples to oranges, I would have to reverse my numbers. I would then say my ratio of oranges to apples is 24 to 12, where my ratio of apples to oranges is 12 to 24. Let's look at how this works with our teddy bear suns and hearts. Here it says teddy bears to hearts. How many teddy bears do we have in the picture above our chart? We have 1, 2, 3, 4 teddy bears. How many hearts do we have? We have 1, 2, 3, 4 hearts. It wants to know the type of ratio in this set of data. In this particular set of data, the teddy bears represent a part and the hearts represent a part. So this is a part-to-part relationship. And then I can write that in fraction, colon, and word form. Just like any other fraction, I can simplify them, and I should simplify them. But I'm not going to simplify it to an integer because it has to have two numbers, because the ratio definition states it's a comparison of two numbers. So we have to keep two numbers there. So here we want teddy bears, which is 4, to hearts, which is 4. Although 4 over 4 equals 1, I still need to keep it as two different numbers. So I'm going to write it as 1 over 1. Then I can write it in colon form and word form. The next question is the exact opposite of the one above it. This one wants hearts to teddy bears. In this case, it's not going to change anything because we have the same number of hearts and teddy bears. So in the end, our answer matches. We're still dealing with part to part. We have 4 hearts and 4 teddy bears, which again simplifies to 1 over 1 in colon form and in word form. They all are read 1 to 1. Here we have suns to hearts. Take a second and identify which type you think this is. Is it part to whole, or whole to whole? Very good. Suns represent part and hearts represent part. So this is a part-to-part relationship. How many suns do we have? 1, 2, 3. How many hearts? 1, 2, 3, 4. Again, making sure that we give it in the same order the question is asked. 3/4 will not simplify, it's already in simplest form, so then I can write it in colon form, 3 to 4, and in word form, 3 to 4. And our last one. Here we are asking for the ratio of suns to total shapes. What kind of relationship is that? Very good. The type of ratio is a part to whole, where we are comparing the suns, which is part, to the total shapes, which is the whole. We have 3 suns, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 total shapes. So 3 over 11. as a ratio that is read 3 to 11. 3/11 is already simplified, so we can write that in colon form, 3 to 11, and in word form, 3 to 11. Moving on to part 2, we've already talked a little bit about simplifying those fractions. So let's see how this works. Here we have the ratio of squares to circles. Again, that is a part-to-part relationship. It wants squares, which we have 1, 2, 3. So we have 3 squares. To circles, we have 1, 2, 3, 4, 5, 6. When I write that as a fraction, I can then look at it and say, well, they're both divisible by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. So my ratio in simplest form is 1/2. Our next ratio wants to know the ratio of circles to triangles. Again, pay attention to the order. In our picture, the triangles come first, but we want the order of the question. The question wants circles first. 1, 2, 3, 4, 5, 6 of them. And then triangles, 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, both of our numbers are divisible by 3 in this case. So we end up with 2/3 as our ratio in simplest form. These are what are called equivalent ratios. Equivalent ratios are two ratios that have the same value or same simplest form. They can both be simplified to the same fraction. So 6/9 is equivalent to 2/3. 3/6 is equivalent to 1/2. So let's try some together. It says find the value that makes the ratios equal. It's easiest to deal with ratios when they're written in fraction form. So the first thing I'm going to do is rewrite 4 to 8 as a fraction. 4/8. And I want to know what it's equal to as 2 over something else. I look at my numbers that match. Here I have a 4 and a 2. How can I get from 4 to 2 using either multiplication or division? In this case, I can divide by 2. So 8 divided by 2 is 4. So 4 to 8 is equivalent to 2 to 4. They represent the same value. Our next ratio of 3 to 5, we're going to rewrite it as a fraction. And then we're going to look at the second part. 12 over what? Well, in this case, I'm getting bigger. So I would multiply 3 by 4 to get 12. I do the same on the bottom. 5 times 4 is 20. So 3 to 5 is an equivalent ratio to 12 to 20. Example C is already in fraction form. In order to get from 45 to 5, will I multiply or divide? That's right, I'm getting smaller, so I need to divide. What do I divide 45 by to get 5? 9. So I want to do the same on the bottom. 81 divided by 9 is going to equal 9. So 45 over 81 is an equivalent ratio to 5 over 9. This time, you'll need to shut down the computer and go ask the substitute for the worksheet for the day. When you are done with the worksheet, you are welcome to get back into Google Classroom and play the ratio games that I have posted there. If you do not finish the worksheet before the end of class, you need to finish it for homework over the weekend. You are also welcome to play those ratio games on your Chromebooks or any other internet device at home this weekend. Have a great weekend. I will see you on Monday.